Hey everyone, welcome back to another video. If you're new here, welcome. Today I have to introduce to you guys 4 new research papers for you guys to look into. And if you find them interesting, feel free to check them out in the description below. I'll link all those papers. Okay, so let's get started. The first paper is called Quenviel, and this paper introduces a new large vision language model, which is basically a vision language model that leverages large language models. And this model is capable of handling a wide range of vision and textual tasks. It accepts image, text, and bounding box as inputs, and it outputs text and bounding box. So most vision language models are only capable of handling text and image. And there are several models that are capable of handling bounding box, but its performance cannot be compared to Quenviel. So Quenviel is actually my favorite new vision language model. It outperforms pretty much every other open source large vision language model you can find. And from this graph, you can see quantitatively that this is true. They actually have a demo so you can actually check it out yourself. I tried it and its performance outperformed pretty much every other large vision language model that I know of, like Yavar, Blip2, Instruct, Blip. It outperforms every single one of them. Okay, so let's go over some of the features of this new large vision language model. Well, first, strong performance, like we mentioned. It significantly surpasses existing open source large vision language models on multiple English evaluation benchmarks, like zero-shot captioning, VQA, doc VQA, and grounding. So VQA stands for visual question answering, if you're not familiar with the abbreviation. And it's also important to note that it supports Chinese as well, along with English. So that's actually pretty huge because some of these models are only capable of handling English. And this model outperforms those models while being capable of handling Chinese as well. So it supports multilingual conversations, so you can prompt it with Chinese or English, and it's able to interpret them. And it also can recognize Chinese and English in the text of the images. So that's really cool. It's actually able to understand the text in the images very well. The best model before this was probably Yavar, which is the Java model instruction tune, visual instruction tune on a bunch of images containing a lot of text. But this model outperforms Yavar by far so far. So yeah. And furthermore, it also supports interleaved conversations. So this means you can input multiple images and compare those images and ask questions about the specifics of each image. So that's really cool. Many of these models are not capable of that yet. So this paper is very important. You should definitely check it out. It's not too long as well. Okay? Right. And the next paper I have to introduce to you guys is called Legal Bench. So what is this paper about? This benchmark aims to tackle the question of what types of legal reasoning can large language models perform, right? So this is moving towards the utilization of large language models in law. So it might be able to help lawyers, judges, right? All that sort of stuff. This paper was actually really long. It's over 140 pages, I believe. So they spend a lot of time working on this paper. You can check it out if you're interested in legal systems, or you can skip this part if you're not interested. So basically, the benchmark consists of a total of 162 tasks, which is a lot, covering 6 different types of legal reasoning, and is intended to facilitate cross-disciplinary conversations about large language models in the law. Right? So that's the purpose of this paper. So let's go over some of the specifics of this data set that they provide, the benchmark. So this legal bench is built by involving legal professionals. So they actually ask legal professionals to help them build this data set. And also they included some existing legal data sets. They mix them in with this data set they're building. So it becomes a benchmark. And the results, well, as a baseline demonstration, the authors test 20 different large language models on this new benchmark. The models include Bloom 3B, from small to large models, right? Bloom 3B to GPT-4. I believe they'll also include Claude and Claude 2, right? And basically on a bunch of tasks, the result is too long to include here because they actually have like a 20-page result section in their paper. So if you're interested, please feel free to check out the paper, which I will link in the comment, in the description below. Okay. Yeah. And the performance is extensively evaluated according to the categories. They have these categories: issue spotting, rule recall, rule application, rule conclusion, interpretation, and rhetorical understanding. So yeah, 6 different types of legal reasoning, right? Okay. Let's move on to the next paper. So this paper, I'm pretty sure most of you have heard of already. It's called Seamless M4T. I'm kind of late to this party because my upload schedule has been terrible, man. I've been trying to upload, but I've been super busy. So I prepared the information already, but I just needed to record the video. Okay. So what is this paper about, right? This paper introduces Seamless M4T, a single model that supports speech-to-speech translation. So you can put like English and it will produce a speech in Japanese or Chinese or Hindi or whatever, right? And it also supports speech-to-text translation. So you could input something in Chinese and the text will be in English, right? And it also supports text-to-speech translation. So you can enter something in text and it will play out like something in another language. And text-to-text translation, basically Google Translate, right? Like we're all familiar with that. And also automatic speech recognition for up to 100 languages. 100 languages is a lot, right? It covers pretty much all the common languages you will see and also some very unpopular languages, right? So this model is quite important. 100 languages is a lot. So this is definitely a significant contribution. So on the Floors dataset, I hope I pronounced that properly. This model sets a new standard for translations into multiple target languages, achieving an improvement of 20%, which is quite a bit for metrics, over the previous state-of-the-art indirect speech-to-text translation. So this is a huge feat, and yeah, this model is just very useful overall. This paper is also open source. They provide a demo that you can try. This is why I love Facebook Research, because they provide really cool demo that you can just try out. Like you can also try out the SAM model, also by Facebook. It's super cool. And Facebook open source all their stuff, man. All their research, they're open sourcing all of them. So I love Facebook Research. So you can definitely give it a try. It's incredible. So what are some possible impacts of this paper, right? Well, it just makes translation easy, right? You can translate films and movies into other languages. As a tourist, you can easily communicate in foreign countries, right? So I just thought of these from the top of my head, and you can definitely think of a lot more applications that you can use with this model, right? But keep in mind, though, that this model uses an A100 GPU, which is quite expensive. Okay, and the last paper is called VisIT Bench. I hope I pronounced that properly. So what is this paper about? It's another benchmark, right? This paper introduces a new benchmark dataset and evaluation methodology for evaluating vision language models on their ability to follow instructions and engage in chatbot style conversations. So I'm a huge fan of vision language models. I think they're incredible. And this basically provides a new benchmark dataset to evaluate it. And I think that's super important. A huge issue with large vision language models is that we're having a difficult time evaluating them because traditional metrics such as CIDR don't really work for this kind of model, right? There has been several research papers that basically came up with this conclusion. So we probably have to produce a new benchmark. And this is what this paper is about. Right? This data set tries to emulate real world use cases, which is awesome because that's why we're using these models in the first place, for real world use cases. It covers 70 diverse instruction families that chatbots should ideally possess. So again, it's based on real world use cases, right? For example, some families include VQA, visual question answering, right? Graph reasoning, which is super important, writing a story, etc. So graph reasoning is quite difficult. Quenviel, I believe, is actually quite good at graph reasoning, so you should give Quenviel a try. So obviously, visual question answering is a vision language task, and so is graph reasoning. Like you can ask a graph some questions like, what is the sale in 2022, right? And based on the histogram, it will provide an answer. Okay. And this paper revealed that current vision language models still have significant room for improvement in many instruction families. And that's absolutely true. I believe vision language models are still in their infancy. They're still not that developed or as good as large language models, right? So definitely we'll see improvements in vision language models in the future. Just like we saw Quenviel, right? This is a huge improvement from existing large vision language models. Quite the mouthful, wow. Yeah, so that's it for today's video. I will link all these papers in the description below. If you have any questions, please feel free to ask them in the comment section below. And if you have any suggestions, please give me suggestions so I can improve my future videos. And yeah, if you guys have any content recommendations, please let me know as well. Yeah, so that's it for today's video. I hope you guys have a fantastic day and see you next time. Bye.